Alright, in this video we shall be talking about the limit of a ratio of growth, and we have been asked to evaluate this function e to the x and over xn as x approaches infinity. And the reason for this question is that this question tells us how we can evaluate exponential and simple variable and compare its growth as x tends to infinity. What is the behavior of the exponent and what is the behavior of this man, where n is a set of all natural numbers, where you can pick any value for n. Even if you can pick any value for n, what is the behavior of this exponent here? So now limit allows us to see the behavior and allows us to conclude what the behavior of this man is. Now the first thing we do here is that we input our value infinity and see the behavior. So let's go. The limit as x approaches infinity of e to the x over xn is equal to e to the infinity all over infinity to the n value. So now we know that e is a constant value to a very infinite value will give us an infinite value. Now an infinite value to any value of n will give us an infinite value. Okay, so now this, because we have this result, we call this always the indeterminate function. That is, by plugging x as infinity, we can't say anything about this function. So what can we do here? Is there a rule that allows us to solve this function? Yes, and that rule is called the L'Hopital's rule. So let's apply that to this function and see what is going on. So using the L'Hopital's rule, and that rule says that we should apply derivative to each component part of this function. That is, the derivative dx, this x is the variable we have on the limit as x tends to infinity of e to the x over xn is equal to now d dx of e to the x all over d dx of xn. So after this step, just differentiate the function independently. So to find for e to the power of x, we know as it is that this still remains e to the power of x after you find its derivative. It still remains the way it is over. When you find the derivative of xn, you get simply n factorial. How do we get this? By saying that when you are asked to find derivative of y equals to x squared, you know the result is the y dx is equal to 2x, just by saying the 2 multiplies the x and take away 1 from the power. Now that is so simple and basic because you have a constant power. Here we have a power that we don't even know what it stands for. Now this is n here, so in that case we will be asked to find not the second derivative but the nth derivative of this function. So to find the nth derivative of any function, all you have to do is to find its first derivative, second, maybe third or fourth. Why? Because you need a pattern that tells you what to do and how to find its nth derivative. Let's go. Now let's find the first derivative. The first one, dx of xn is equal to this xn here, right? Now we have n into x n minus 1, right? That's the first one there. And the second derivative here, the 2 all over the 2x to the xn is equal to n minus 1 to x n minus 2. This is because every time you always remove 1 from the power. Now, are you seeing a pattern here? And pattern is this: when you have 1 here, you have 1 here. When you have 2 here, you have 2 here. Let's do the third one and see what we get again. Now, the 3 over the cube x of xn is equal to n minus 1 to n minus 2 to x n minus 3. Now, when we have, now see a pattern again, 3 and 3 is here. Now assume that we have k. Assume that we are finding the kx over to xn. Now assume we are finding the kx of xn. That simply just say that. That simply says, see, when we had 1 here, we have 1 here. When we have 2 here, we have 2 here. When we have 3 here, we have 3 here, right? Okay. When we have k here, then obviously we should have n minus 3 and k. But because we don't really need what is almost at this end, because they will vanish to 1, so we just simply say we have n minus k, because we are finding the kth derivative. And if that happens, you know what you know is that this man comes down and multiplies the s and will remove 1 from the power. Now we know that. Now assuming you are finding the nth derivative of this function here, xn, that means you are just saying just let k be equals to n. That is all. Let k be equals n. So you have the n over the nx of xn, which stands for the nth derivative of xn. The nth derivative of xn is equal to n to n minus 1 to n minus 2. You know, we still have n minus 3 to n minus k plus 1 like that, all the way to x n minus n, because whatever is here must correspond. 3 correspond to 3, 2 to 2, k to k, so n must correspond to n. Now, because we have this becomes the nx of xn is equal to n into n minus 1 into n minus 2. You know, I can keep writing it, then into x to the power of, here we have n minus n is 0. So n minus n is 0. We have x to the power of 0. And n to the power of 0 is 1. 1 times this system is this system. But you know that this system keeps on going because we have it as the n derivative. So we have the n derivative of xn is equal to, because this system keeps on going, and when you have n to the power into n minus 1 into n minus 2 into n minus 3 all the way, we call it n factorial. So the n derivative of xn is equal to n factorial. That will bring us back here. You see, we have n factorial. Now we can plug in our limit and see what we get. So now here the limit as x goes to infinity of ex over n factorial is equal to e to the power of infinity over n factorial. Now we know that this n is obviously a constant. We know that for sure, that this n is obviously a value. Now pick any value for n, any value of your choice. Now pick it for n, any value. Let's pick 2. Now 2 factorial is simply 4. Okay, now this remains the way it is not changing. This is a constant to infinity. Now you should know that this value is obviously above this 4. Now pick any value for n, this is always above it. Pick any value for n. This is now this tells us the ratio of growth, the ratio and growth of this limit. No matter the value for n, this exponent will keep on increasing. Thank you as you stay this long. See you in the next video.